I would like to talk about why smaller textures are actually faster, and should I just say smaller is better? For the textures, of course, and not only them. Well, here you will see that the less data you have, the less computation you need to do in your GPU and on your hardware by itself, by just transferring the memory in between. So let's get it over with. So moving on. First off, a texel. A texel is pretty much the very one small pixel. You can imagine the texture. You have the UV on the texture, so X and Y coordinates, and each like this colored small thing on texture is called a texel. And we can have many different texels, right? We can have 2K, 4K, 1K textures. They can have very different size in terms of texels. And also it changes the memory size. And also it depends what's actually stored on the texel, because, well, you can have just one 8-bit value. So for example, red channel 8, and also you can have RGBA values. So RGBA 8 or 32, and it goes on and on. And for example, typical RGBA 8, you can have 4 bytes per texel. It's like the common most default value. Then you can, for example, have HDR, which is twice as big. Then you can go into compressions, and you can have, for example, 0.51, 0.25, and it depends on the platform and what's supported for the different textures. And some engines give you by default some options to compress something. The other engines do not give it. So it's sometimes to check what's going on and whether or not your texture can even be compressed. The best rule of thumb is to have the texture as power of 2, because it's simplest to have the compression on. And well, remember that not compressed texture, compressed texture. This is compressed, this is better. This is better. As the rule of thumb. And if you're scared that your compressed texture will need to be decompressed on the GPU side, you have already some hardware units that do it for you. And in shader, the code stays the same. And for the GPU, it's actually faster to just decompress it and use it instead of just processing the whole big memory chunk that is the uncompressed texture. So it's just a good trade-off that you can find on many benchmarks, that there's either no change or we get a benefit in terms of performance. So it's good, okay? And what also wants to think about is the texture dimensions. So for example, the higher we go, the more it scales in memory. And for example, the 8K texture, don't use 8K, please, but it's like 360 megabytes. The 4K by default could be like 90. And whenever you want to use a texture, you want to think about how many pixels does the texture cover. Is this a full screen texture on a full 4K monitor? And okay, let's use a 4K texture for the background because it's visible all the time. And well, it's useful. But if it's a small flower somewhere that's visible for maybe 100 pixels, then you can just drop a 256x256 texture, and it uses way less memory, is way faster to compute, and it's just way better. And of course, we need to think about the disk size, because some projects have now hundreds of gigs of like disk size that you need to download and process and whatever. You can just have way smaller textures. Of course, it takes time, but it's good time because you get performance, less disk usage, and also it's just faster to compute. So they're only good things, right? Less memory, faster to compute, less disk usage. Then, how much detail do you actually need, right? So again, literally just test with your eyes whether or not something is good. Like 16 by 16, okay, too blurry. 64, looks like I didn't wear my glasses. But 256x256 looks fine. And 1K looks pretty much the same. The difference, I use more memory for 1K. And this makes it so there's more disk usage, is slower to compute. So I can stay with 256, okay? Test it with eyes, looks fine. It's very simple. And moving on, we can do the same for like some 2D shapes, and it's more important for things that we focus on. So some objects of focus, or for example, some faces, right? So we want to recognize what's going on and whether or not something is acceptable or not. And here we want to be a bit more pedantic on the textures. So sometimes we can give ourselves a buffer of the size. So pretty much 512, better than 256. 256 looks okay-ish, but maybe drop a 512 because we have this developer bias that it's good enough, but it's actually bad. So it's good to think about it, right? Just have it somewhere back in your head. Of course, 256 can still be okay, so it depends on what people will say about it. So, take some feedback, ask. It's nothing much really, just a moment, and to change it in an engine or app, it's really simple and fast to do. Next thing is, what's the GPU hierarchy actually? So why is the processing faster? So logically, you can think that the more memory you have, so the more data you have to process, the longer it will take, right? You have more data. It's logical, right? But how does it look like in memory? So first off, you have the system RAM. You need to get something from RAM. And God forbid you take something from disk at runtime. But let's say it's not that bad and you take something from RAM. And you have like 1,000 on average. Of course, all those predictions here depend on the hardware, but this is like some approximation of average data. So pretty much, let's say for the system RAM, around 1,000 cycles, and the speed of getting that is around 32 gig. Then you can get something from VRAM, and it's like 400, 800 cycles, and it's 0.5 to 1 terabyte of speed per second to like get the data. And then we have the short L2 cache. It could be, for example, 2 to 100 megs big, and it takes around 200 cycles, 3 tera per second. Then L1 texture cache, we have different modules for the textures, as I said, to, for example, decompress it, store it, and handle it. It's like 20 to 40 cycles, but 16 to 128 kilobytes, and it takes 5 tera per second. And then we can think about it that, okay, it's 10 terabytes per second. But okay, I have that, but my texture has like 90 megabytes. So I have a lot of those cache lines to load from the memory. So for example, from the VRAM, it gets loaded to my L1, then it maybe gets dropped to L2, then it maybe gets loaded into registers, and it just moves between all of those. But the bigger the texture, the more fetches I need to do from the memory. So the more things I need to load, and it just takes time. So the smaller the texture, the less loads I have into my caches and register files, and the faster it is. It's that simple. So I don't want to break the contiguous memory that I use. And also, in a bit, we'll talk about the memory reads of what's going on, because sometimes you don't just read the texture linearly, you do some weird showabanga. And let's go straight to it. So the texture pretty much rewards the locality, and whenever we try to read the texture normally, so we go linearly, bam, 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 whatever it is, it goes linearly, the cache loves us, and we go with the cache. Of course, depending what's the hardware, how exactly the texture is stored, but usually the cache loves us. And the bigger the texture, the more we have cache misses. A cache hit pretty much means that we already had something in the cache and we can load it instantly instead of fetching it from the memory. A cache miss means that we need to eject things from the cache and get things from the memory. It's called like cache eviction, but well, yeah, you get the idea. Then the hardware, with the progress of the hardware, it went in a way that it is way faster to compute some floats, but it is, in comparison to how faster it is to compute floats, the memory did not catch up that much in terms of hardware performance. So the current bottlenecks very often in terms of graphics programming or just handling some graphic applications are just pretty much the memory issues related to it. So we want to have actually smaller textures and transfer smaller amount of data between our hardware, because, well, the memory transfer is not as fast as it could be. And then what we want to remember, there are mipmaps. And mipmaps is pretty much our texture, but in the smaller versions that our hardware just swaps for us. So we have, for example, 1K texture, the hardware creates 512, 512, 256, 256, and goes 1 to 1x1. So pretty much the power of 2 textures. It's stored for us and gets swapped at the runtime. And it's very useful, right? But sometimes it's useless. For example, we talked about the background texture. There's one big background texture. It's useless with mipmaps. You just waste memory for it. Like, you never use them. So why? I ask you, the developer, why? What's going on? All of this works if it's linear. We love if something is linear because the cache loves us, hardware loves us. It's great. What if there's some shimmer, aliasing shimmer? You can see that for the coherent sampling, everything is fine. Everything is loaded in the cache line. There's some prediction for the cache, and everything is fine. But sometimes some algorithms, some options to use in software for the 3D scenes. So pretty much when you use something for the 3D scenes in your software, you can have some algorithms that just use some many round trips or random shimmers or whatever data algorithm that pretty much just break your locality, and they read at random samples in the textures, and the cache hates us because we read at many different places. And the bigger the texture, the more likely we'll have a cache miss and we'll need to load something from memory. And as you know already, it's slower. And when the texture is like big, let's say 2K, 4K, 1K, 1K, of course you can say, yeah, it's not that big, that's fine. Well, it scales up in the projects and later it sucks. So it's good to think about it. Of course, memory-wise, disk-wise, and performance-wise. So remember it. And then the smaller the texture, even with those algorithms that are, well, not as optimal for the cache as they could be, still, it could be fine with smaller texture. So think about it. And moving back, compression. The compression makes it so the texture is both smaller in memory and faster to compute. And I want you to remember it because it's very simple, right? Smaller in memory and faster to compute. And you like compression, you want to use compression. If some software needs something to use the compression, like it requires you to have power of 2 texture, you make the power of 2 texture because it will help you a lot. The compression is very helpful and it does not go in a way as mipmaps. So if you have this big background 4K, you want it compressed as well because for 4K it's a lot of damn memory and it's slow. And if you compress it, it's faster. And that's all you need to know. Like, you don't need to know the technical details about how the algorithm actually compress and decompress this stuff. You need to know that it's just faster. And if you don't believe me, just check up some random benchmarks, whatever you find on the internet, ask AI, whatever. You will see that it's better. And that's all you need to know. The guidelines. Use compression by default whenever you can. For anything. It's useful. Ship mipmaps for anything that is not full screen backgrounds, whatever texture. Match the density to screen. So think about it. How many texels do we actually need for this texture? Like on how many pixels it will be? That's very simple. Repeat often. Use the same textures if possible, because they stay as one object in memory, in disk space, and as one object to compute. It can be cached. It's good. Don't oversize just in case for certain objects. Like, don't just be like 512 is fine, then let's throw 2K just to make sure. No, test it, ask people. As I said, test, and test it. Of course, you can say it's very pedantic, but, well, today's game have performance and it's good to fix it actually. Then profile. So pretty much VTune, rendered, whatever it is, profile. On CPU, sending some data to the VRAM. Is it slow? Is it fast? Because sometimes you might be loading something during the runtime. Sometimes it can be just whatever is already on the GPU and it's slow. So like RenderDoc, NVIDIA, and whatever applications. Just use it, profile it, do it for yourself. And it's pretty much what I wanted to show you guys. So remember that smaller is better. Thank you for watching.